Good afternoon, and welcome to what I believe will be a provocative but critical conversation about the role of AI in manufacturing. My name is John Dyke, and I'm the Chief Executive Officer here at CESMII, the Smart Manufacturing Institute. And I'm truly honored today to introduce to you a remarkable set of thought leaders representing a wide range of industry, business, technology, and academic expertise on this topic. Our efforts here at CESMII are to take a vendor and technology agnostic approach to establish the areas of innovation and development that will accelerate the democratization of smart manufacturing. We will invest over $140 million over 5 years in technology innovation and research, education and workforce development, and business practice transformation to do just that. So we're laser focused on understanding exactly and holistically what the challenges are that constrain the broader adoption of smart manufacturing technologies like AI and machine learning in manufacturing operations. Our investments here will then serve to bring this ecosystem together to reduce the cost and complexity of these initiatives and see the use of AI at scale in manufacturing. There's still a lot of hype around this space, which isn't unusual when you have the potential to disrupt an entire industry, but that makes it even more important to understand the distinction between what's still aspirational and what's pragmatically achievable. Let me be clear, the value of AI in manufacturing is enormous, but so is the potential to become a statistic in what I'm sure you've heard of as pilot purgatory. The 70 to 80% of Industry 4.0 projects that start with great intentions and much fanfare, but don't actually end up creating the value that was expected. This obviously becomes a significant headwind for any subsequent efforts to invest in and scale up these types of efforts in your organizations. With that said, I'm excited to introduce our panel to you. And with each intro, I'll include a warm-up question just to keep it interesting. Let me start with Jeff Kent of Procter & Gamble and a high-level outlook of AI in manufacturing operations. Jeff, would you introduce yourself and then share your perspective, perhaps a brief State of the Union on this topic?
Yeah, thank you, John, and thanks for the opportunity to speak today. Yes, I'm with Procter & Gamble, and I lead our smart platforms efforts from engineering as we try to impact our product supply operations globally to make our equipment, our processes more intelligent. And so, at Procter & Gamble, we have operations around the world. We have thousands of equipment value streams, which we would like to make intelligent. The reality is some of them are very mature, some of them are immature, some are working from different OEMs, some are things we designed ourselves, yet the opportunity for smart manufacturing or intelligent operations is very, very large for us. Yeah, we've got to figure out a way to take those opportunities, whether it be for digital quality assurance, preventative maintenance, transparency, and trust, and make them real in manufacturing environments that have not been so efficient to this point with data. So, John, for us, we're looking for this democratization of data. We're looking for that data to turn into data products that then we can apply machine learning methodologies to. But there's a particular thing that we've got to figure out in manufacturing for that manufacturing community, and this is why we're in the discussion. We think that Procter & Gamble and our Tier 1 and Tier 2 suppliers represent a microcosm of the industry opportunity, and we think the things that we've solved, the things that we're still struggling with, the things that we're passionate about are rightly part of this discussion. So we're on our way, but we don't think we can do this alone. We think that there still needs to be standards. We think there needs to be infrastructures. We think there needs to be approaches that we as P&G and our overall ecosystem can participate in. But it's clear if we don't do this, we won't stay competitive as a company, and we also won't be competitive as the United States in the same endeavor. So happy to be here for this discussion.
Thanks, Jeff. Great overview. Waleed, technology plays a unique role in this domain. Tell us a little bit about yourself, your role at Microsoft, and how AI is about more than just another technology in this space.
Well, thank you for having me, John, and a pleasure being with the whole several panelists here. Very appreciative of the role CESMII is playing in the industry. And with that, it's really a good pivot point. I run AI and sustainability for manufacturing for Microsoft. Simply put, we are witnessing an era in the industry where a drastic widening skill gaps and technological opportunities are further exacerbated by a year of pandemic unprecedented pressure points that we have witnessed in the industry. It is really a blessing in disguise, because simply for us to be able to come healthy and successful on the other end, we should be able to reflect and prioritize our utilization of how to address this opportunity / set of challenges, increasing digital economy, manufacturing at a competitive edge, being able to drive excellence. All of these are the requirements that AI, artificial intelligence in general, or better automation would help us to address them successfully and come on top of it at the end. For us being able to do that, there is a need. I couldn't have said it better than how Jeff articulated it from his point of view, but we see this as actually a general trend in the industry. We need to partner, we need to collaborate. Us at Microsoft, we're very proud of the set of technology products that we're offering, but we're eager and excited to have the opportunity to partner with industry experts in manufacturing, as well as in any other enterprise discipline. And being able to drive that value add for our community is an unprecedented opportunity that we should all capture. So thanks again for having me with you.
Glad to have you here with us, Wally. Thank you. Kelly, definitions are important, particularly so in this area. Can you introduce yourself and share with our audience how you think about AI in the context of manufacturing operations?
Sure, John. Thanks for having me again. Really honored to be on the panel with my colleagues here. It's a great panel, and of course, we've been a supporter of CESMII for some time. So I've been in the defense industry for about 20 years. I lead a group of system engineers, software engineers, manufacturing engineers, mechanical engineers, manufacturing engineers, that Medici effect of folks that are all working Industry 4.0 in our Raytheon intelligence and space business. It's an awesome team. I'm really honored to lead them as well. And so I'm responsible for that across our factories in the U.S., along with a couple other colleagues that have elements of Industry 4 in them. From an industrial perspective, and again, there's as many definitions as you could find on the internet for AI. So I don't think there's one single definition. So I'll just give my perspective here. Really the element of AI versus advanced analytics and machine learning is that additional ability to reason and actually suggest or make decisions that are actionable. As part of that, you have to sense, you have to perceive, has to learn. Machine learning is a key element of AI. You'll often see those, of course, one after another, AI/ML, and that's certainly key. And of course, there's some fuzzy lines in between there, right? It's not a firm delineation between all three of those. But at the end of the day, I think AI it's farther reaching than machine learning, and it adds that additional element of reasoning and really providing solutions, suggestions, decisions, versus just a prescriptive analytic.
Outstanding, Kelly. I think that's a great practical approach to this domain. Let me shift to you, Jim. Jim Davis, you've been involved with AI for many years, including the first surge of AI interest back in the, dare I say, 80s and 90s. Does the long haul perspective inform the opportunities we see today?
So John, let me start like the others. I've really been looking forward to this panel. It's a pleasure to be here. So from an introduction standpoint, let me just kind of pick up on this long haul word. And I'll be in danger of carbon dating myself here momentarily, but I'll move it to the present. When I started back with Amoco Chemicals, we were worrying about analog to digital. So just this digitization thing, which was 30 years ago. In the first surge of AI, there was no internet, there was no big data, but we really understood what domain knowledge or subject matter expertise how it was needed, what it was needed to do, and that computer science couldn't solve all of these AI problems. Crossed through some CIO roles, and people remember the age of ERPs. But what that really did was it got us thinking about thinking horizontally, thinking about enterprises. Then the internet came along, then supercomputers and modeling came along, and this is about the time cybersecurity became a thing, because there was a time when it wasn't. Going back, if you look at smart manufacturing, where we were getting started with that, that was the result of the advent of cyber infrastructure and rethinking the location of IT resources and what does that do. And that was actually the precursor of cloud. Then the Manufacturing USA Institutes came along, and a lot of interest in how to scale and how to take these technologies forward from a manufacturing competitiveness standpoint. So if I kind of put all these together, we're in the second surge of AI, as I like to call it. We now have a means to use AI. We now have a means to use the network. We now have a means to think even broader than the enterprise. We can think in terms of supply chains and ecosystems. And where I see, and it's entirely consistent with the other comments, manufacturing and industry has yet to rethink itself. It has yet to really understand how to reorient itself to take advantage of all of these to get to the full opportunity. I put this under the term digitalization, and we're just at the start of that, and that's why this panel is so important, because there's some hurdles and barriers to get over, but there's a huge opportunity in front, with AI being a part of all of these technologies that have come forward for about 30 years now.
Yeah, that's a great sort of long-term perspective on where we are today. We're clearly not novices in this, but there is still a significant, given what's happened from a technology and a platforming perspective, there are significant new opportunities for us to sort of re-engage in the space and rethink, to use your word, rethink and reorganize ourselves to truly drive these capabilities forward. Last but not least, Jonathan, we're going to hear, as you introduce yourself, that your career over the past 20 years has provided you with a unique opportunity to see this domain through the lens of both IT and OT. Can you speak to that briefly and the unique set of skills that are required to come together as we begin thinking about how to scale out AI in manufacturing?
Yeah, thanks, John, and thanks for the opportunity to be on this panel. I'll echo the sentiments. It's a real privilege. I'm our VP of Technology here at CESMII and the architect for the different technologies that we're trying to pull together. I got my formal software development education out of a School of Business program, but I landed my first development gig writing software for and about industrial automation equipment. So it was a bit of an awakening. It forced me to learn to translate ideas between IT and OT very early in my career. I spent about 10 years writing information software for manufacturing systems, and then another 10 influencing and then leading new technology development, with the last two products heavily looking to AI either as the core of the product or as a significant input for how the product worked. And I think it's a reality that we have some different considerations when we're deploying technology in manufacturing. There's obvious things like the environment is different, the compute surface on which you're going to run is different than what we're used to in IT. There are operational considerations, both the operator, the person who might want to react to a decision, or the system into which a decision is pushed back is different. And there's the relative anarchy of the data pipeline in manufacturing. There's a lot of different systems, a lot of different sources of data that need to be wrangled. But even though these are somewhat unique to our space, I think everywhere that we're exploring AI with has some of its own challenges, and they shouldn't be seen as blockers. Obviously, we have to approach them with empathy. We want AI to serve humans. So we need to be thoughtful about the challenges we face in the different places that we're deploying this technology. And we need to build these systems for the environments that they're going into. But I have an optimistic view that, one, these challenges can be overcome, and two, that the upside is worth the work, that there's tremendous benefit for the workforce, for business, and for building smarter systems.
Outstanding. Thanks, Jonathan. I love the term relative anarchy for manufacturing data systems here. Jim, I'm going to turn to you for the first question, given how you introduced yourself. I thought Kelly did a fantastic job sort of sharing his perspective on AI manufacturing operations from the perspective of the manufacturer. And I don't think we need to spend a lot of time on additional definitions, but I think it might be helpful for our audience if you might take just a moment to briefly deconstruct AI and talk about the different kinds of AI as it relates, again, to this domain here, manufacturing operations.
Yeah, John, sure. Let me, before diving into the definitions, let me just kind of give you a background on the definitions. Some of you are aware, but I would like to kind of make it known that the National Science Foundation and the National Institute for Science and Technology has been really engaged this past year in the role of AI in manufacturing. And so there's been a series of workshops to get at some of the barriers, the difficulties, how to move things forward that we're all talking about. But one of the things we did do with these set of workshops was to take these definitions to a very broad group of people, practitioners, providers, government folks, university folks, and so forth. And the overwhelming opinion on the definition was, don't get hung up on the definition. AI is really just really just meant to be a set of software systems, that can recognize, simulate, predict, optimize situations, conditions, and properties to the benefit of the manufacturing industry and to the benefit of competitiveness. And so, quite honestly, we have been carrying that particular definition through, and would really urge people not to get hung up on a particularly precise definition. It really is, I think Jeff said it, it's about the role of data and modeled systems, to the benefit of manufacturing, and there's a huge amount of opportunity to do so. I'll just mention too that machine learning is really just the way to use data in much richer ways and learn from that data, again, for these competitive sorts of objectives that we all are facing.
Thanks, Jim. I really appreciate the thoughtful response there. I think that puts things in perspective, and I think that aligns us really well for the sort of practical conversation that I know we plan to have here. So that takes us to sort of the why of AI. The opportunities for AI in manufacturing are clearly enormous, and we'll be exploring that shortly. But the phrase pilot purgatory is all too often associated with these types of manufacturing initiatives. Take a couple of minutes, perhaps Jeff and Waleed, I'll turn to you. Take a couple of minutes to share your perspective on why it's proven difficult for manufacturers to scale up from their pilot initiatives like this.
So thanks, John. Maybe let's start with why we did or are doing pilots, and then what the struggle is to transition from them. So as described, we're still in the early phases of applying machine learning and AI to some of our manufacturing industries, particularly for myself and fast-moving consumer goods. So you have to get people into that world of doing data exploration, using hypotheses and their subject matter expertise to build, train, and deploy machine learning algorithms. So once they've gotten through that phase, which is very difficult at times, to get the data, to contextualize the data, to transform the data, expose that data to your machine learning exploration for the algorithms, and then finally bring your machine learning model back to the operation. Once that's done, you have this big opportunity to say, hey, I want it on more than one operation. I want it on not just this line, I want it on all my other 10 packaging lines or my other value streams. And then you realize, well, I don't have an infrastructure that can get the data out in the way I want it. I don't have a platform that contextualizes well, and I don't have a place where the algorithms can be developed very easily by non-data science experts. So we're at that stage, right? We have a number of successful pilots, but they kind of stay within the context of who developed them, and they haven't been democratized or extended to the larger operation. So I think, what we're still in the middle of doing and working very hard with the industry and internally is to take the successes and failures from the pilots, but design with an end in mind in the future. What is the overall life cycle of the technology, the reference architectures, the applications, the machine learning life cycle? Because the other thing we don't talk about, the DevOps and the maintenance of those models once they're running is as important as you developing them. So I think for P&G and the industry, making sure that we can build a set of standards, data infrastructures, profiles, I'm sure we'll talk about, and in the application space by which the sensors, the data transformation, the data products, all the way to the machine learning and the running of those can be done by non-experts, right? I think in the automation industry, which many of us came from, it does take some time for these early technologies to get commoditized in a way that anyone can apply them, that doesn't have to be the only 5 experts in the industry that can do this. So I think we are coming out of the pilot purgatory, but we're only going to sustain a scalable adoption and achieve the whole promise of Industry 4.0 when all those come together into a full work process and a full set of applications that P&G, our suppliers, the OEMs, and all can participate in. So I'm confident, John, that although we've had to spend the right time in MVPs and pilots, and we still will, that I'm hopeful that with the commitment of the industry, commitments of CESMII, Microsoft, and others, that we will offer the scale benefits very, very shortly, the way that other industries have.
Thank you, Jeff. I think it's great to continue the conversation from where you left off. I would only be able to pile on what you just mentioned. I think the best way to look at it, let's kind of step back. For any enterprise sector, manufacturing being one of them, it has been that maturity journey that started with understanding the value of AI and congruence between utilizing artificial intelligence and machine learning in general into meaningful workflow productivity tools. And it has been a challenge that differed with a different maturity path for every industry, has been dependent on the industry's ecosystem, investments from the government in that sector, investments from private sector in the space, and the desire to modernize to catch up with competitiveness. It really differed. I mean, financial sector, comparing to healthcare, comparing to manufacturing, here in hand, which, by the way, we're coming now as a society to realizing that manufacturing is the fundamental foundation to all other enterprises, which is really adding more tailwind to the value we bring in. So that's kind of that macroscopic view of where the maturity journey has been looking the way it has been looking. You kind of compound that with really the laser focus examples that Jeff mentioned, with the issues related to, for lack of a description, having an AI run in separation, kind of complete isolation from the main workflow to prove value before you start integrating it. And he started even giving you a few examples that I couldn't agree with him more regarding DevOps, DevOpsSec, being able to drive meaningful changes in the workflow as insights from AI and machine learning have been providing us in a meaningful way to impact operations, cost models, and also agility and sustainability of our production. All of this is where we are, and we as a society are in today. It is also evident that our drive here in North America to have the disruption needed for manufacturing is further powered by the current policymakers' direction support, both in the Congress as well as in the White House, and being able to utilize all of this to address the next wave of challenges will further accelerate our ability to integrate the goodness that come out of AI into the mainstream manufacturing. I do believe now the gap is being closing, and it depends whether you are at a large enterprise or at a small business, maybe at different pace, but the whole ecosystem is maturing. This time is opportune for all of us to really embrace, kind of, let's acknowledge the challenges or the journey that we've been through to make value of AI in our day-to-day business. But time is now opportune for us to drive value for our business, for all the slices of the value chain, while also partnering with the right ecosystem to drive that execution.
Great summary, gentlemen. I think what I heard from both of you, both explicitly and implicitly, is that we have to think about this as an ecosystem, that this is not an opportunity or a value proposition that any single set of stakeholders in this value chain are going to accomplish on their own. So I think that's a really important message. Thank you. So the next question I'd like to turn to, I'll start with you, Kelly, and then ask again Waleed and Jeff to chime in. what are the areas within manufacturing where AI can have the most significant impact? We talk about manufacturing operations here. I think we can expand that a little to the impact of manufacturing on the supply chain. But what are the specific areas? Again, Kelly, starting with you, where AI can have the most significant impact?
Sure, and of course this list could be very long, but I'll hit a couple of the key ones that I think are important. And just starting off with one that's near and dear to every manufacturer's heart, which is quality. When we think about yields and correlation of yields within a manufacturing process, and I'd say especially for some of those process-intensive manufacturing processes, such as mixing, things that have a significant amount of variables that go into that particular process. So being able to come up that yield curve very quickly versus typically those processes utilize design of experiments, which will still happen, but AI can be a significant accelerator there, and pulling things out of integration of hardware and system tests, I think is a key area. Certainly factory scheduling and optimization. I think it also raises some very interesting topics with traditional lean. How do you, if you're optimizing your schedule constantly with AI, how does that impact lean? But certainly that is an area where optimization and digital analytics can make a huge impact relative to AI. And then I think some of the things that we've been dealing with within Raytheon, machine vision is another big one. So machine vision is becoming really commoditized, but the ability for that machine vision to pick up what you want to pick up every time and improve itself is a significant endeavor. And so then just a few honorable mentions: design for manufacturing and cost modeling, asset utilization, of course, and then lastly, that's kind of a side, not a side note, but an important element, maybe not in the core of manufacturing, but it has to be part of that infrastructure, is cybersecurity. So being able to look at cybersecurity, whether it's monitoring the systems, whether it's determining new ways to harden your systems, cybersecurity is a big place where AI can play.
So maybe, Kelly, I can build off the quality one. I can't emphasize the quality one enough. For us at Procter & Gamble, delivering irresistibly superior products, packages, and services is our job, right? And in the quality and quality assurance area, we are going through what I would call seismic changes in the way quality assurance needs to be executed. Moving from a world where we would sample products at a high sample rate, take them off to laboratories, and perform tests, destructive tests, other tests on those products to release them, to a fully online, every product at speed set of instrumentation, vision systems, that data model being served in and compared to and combined with the process data, then using machine learning algorithms to either do process control strategies or automatic control and release. Just seismic changes that we're really obligated to deliver. And then on top of that, our consumers today want to know everything about the product that's possible. They want to know what's in it. They want to know how it was produced. Is it sustainable? What energy do you use to produce it? Can you produce evidence that you have not done anything as a negative transformation that it might affect them? So the data model and birth certificate about our products, combined with the process data and the quality assurance data, all being managed as part of a body of evidence about quality and a body of evidence to produce for the consumer to validate themselves as they purchase it. There's no other way that you're going to navigate that space without machine learning AI and the overall reference architecture that is needed. So we're both intimidated and inspired by, if we do that well, we will secure our place with those consumers and secure our place with the industry. So we're looking to lead the way in our industry and other industries. You talked about machine vision. Those vision systems that we already have, they're transforming, as you said, into these classification machine learning models that can do amazing things. And then those feed into robotics. So the one thing that I would add is our robotics applications for automation and customization are all being fed by classification machine vision algorithms that integrate deeply into the performance of robotics. So, at the subsystem level, AI is primary. At the enterprise level, AI is primary. At the edge processing level that Jonathan talked about earlier, that computing surface, AI and those models we develop so we just have to have the competencies and the confidence and the ecosystem to do these at every subsystem level and at an aggregate level. But I would say, John, you and I talked this maybe a week or so ago. For us, and for me personally, it begins with quality. And then all of this, what I would say the byproducts of maintenance, process stability, all come because you've got a full broad picture of quality performing among all those different data domains. That can't be done without the proper data engineering and machine learning AI. So Wally, hopefully you're seeing the same thing as you explore the industry.
Yeah, I think I'm going to just absolutely couldn't agree with you more, Jeff, and confirming what I heard from Kelly before you. Let me kind of summarize very quickly. I think the Agile Factory with all the operations visibility, as productivity, operations and operations efficacy increase, absolutely slam dunk for AI and AI use case in the future. Supply chain management, visibility, optimization. And then I'm going to actually pivot into trust, which we heard from both Jeff and from Kelly before him. I think fundamentally being able to trust the contributors to our production supply chain and being able to drive value to the end consumer and utilize the best recycled value out of the product in its life cycle in a circular economy fashion, in a trustable fashion, and being able to drive that distributed AI and distributed trust. I think this is really a huge opportunity/challenge that can only be addressed with AI. But let me kind of pivot to one last point that I think we are implicitly talking about it, but let's kind of explicitly mention it. Fundamentally, AI is the best tool to transform your workforce, being able to drive an enhanced set of capabilities for frontline worker, being able to have the right connectivity back to the rest of the organization to have what is meaningful information versus not, being able to drive value on the production floor all the way into the shipping dock and being able to drive that value. All this is associated with crisp and clear set of AI use cases that it can only be further augmented from where we are today into the future. I'm going to actually kind of close on this by saying, naturally, with the adoption of AI, we should be able to drive the understanding of learning and knowledge gaps and opportunities for the partners and ecosystem players, as well as our own staff as well. So I see that transforming the workforce and being able to drive value is a huge opportunity for AI as well.
Thanks, gentlemen. I love the fact that each of you began with outcomes and that the technology pieces, the technology piece and the elements related to how we get there are non-trivial, and that's a big part of kind of where we pivot to next. But it starts with business outcomes, and that's where the justification and where the significant opportunities are to remain competitiveness and drive competitiveness as a manufacturing entity here in the U.S. will drive us. So, Jim, you alluded before to the fact that you have been involved with the co-chairing of an expansive symposium that involves practitioner, provider, government, and I think you alluded to academic experts on the role of AI in U.S. advanced manufacturing competitiveness. Are there some overall themes on the value of AI and from that effort and how to get at it?
Yeah, John, there's a couple things I can kind of speak to and actually build on the prior discussions. Let me first of all pile on the quality assurance point. That one's coming through loud and strong, and it really is the topmost point. The workshops are actually trying to deal with competitiveness from a U.S. perspective, which really means a global perspective. And when one thinks about quality assurance, you actually think about the quality of the assurance during a particular step when something is made, a product or a material, but you actually have to worry about the upstream conditions, you have to worry about the downstream parts of this, and it's the whole collection of these things that actually leads to the overall quality of the product, from end to end, so to speak. And so when you look at it that way, we put it under the heading of horizontal thinking. The industry is very, very good at vertical thinking, but what needs to happen from a horizontal perspective to get at this quality assurance across all these things? And then you start stacking up a whole set of things, asset management, predictive management, optimization, track and trace, all the sorts of things that are going forward. If we take some of the workshop findings, now there's some very interesting points coming out. In light of those kinds of outcomes, when you look at the overall, say an overall supply chain or an overall ecosystem, most companies don't have the right data to put these kinds of algorithms in place, even if they had the ability to do so. They don't have the right data, to get at the kind of precision, the kind of productivity that we're talking about. Everyone agrees that small and medium companies are really key players here, as well as the large companies, the large OEMs. So everyone actually has to play together here to get at this quality sorts of things. And then we always come back, and while you were just saying this, there's the people have to be in place. Nothing's going to happen without the people, without the the right skills. But we have to get the kinds of methods and tools and skills out to all of the people. So the workshop has actually been dealing with some really hard questions about where to start on this. And one of the things that we've been taking forward, or seeing coming through is actually a better way to say it, is that if you look at other industries and you look at how they have responded to the internet and responded to network effects, there actually has been ways to move through move to simplicity, do some bottom-up approaches, have a much, much broader way of having tools and methods that people are starting to expand on. This is that democratization question. And once you start having the bottom-up approach together with a top-down, you can actually use methods to drive the training, drive the skills, drive the benefits that will beget the benefits and start kind of a virtuous cycle, as we call it. So one of the things, we can talk in very lofty terms here, but what we're really talking about, I think, is starting small, in some cases with a small company, one single sensor on the network, and show some benefit, learn how to do that, learn how to use the data, and then start building out from that. And if we can do that across small, medium, and large companies, we create an overall effect where AI is actually facilitating the AI to the benefit of the manufacturer. I'm going for a long time, but there's this how to start an adoption cycle that's really key here, and the industry has to think through the business models to do that.
So that's a perfect thread to sort of build on. We've referred to democratization as an important objective for the industry. This is what AI at scale looks like. So implicit in that assumption is the idea that implementing and sustaining AI becomes so accessible that anyone can afford it, including, as you pointed out, Jim, small and medium manufacturers. Clearly, we're a ways away from that, but with that as the goal, I'd appreciate each of you, perhaps starting with you, Jonathan, to share your perspective on how the various stakeholders in this ecosystem need to evolve toward that vision. Jonathan?
Let me answer this question as a software developer. Forgive me if I get animated, because I think this is really important. So let's talk about a different workforce, and that's the workforce developing this AI to be deployed for manufacturing. I talked a bit about my experience with the IT-OT divide. In IT software, we've talked for the past few years, for obvious reasons, about building software to be secure by design, not just attaching security at the end as an afterthought, but actually doing our design from the grounds up with security in mind. I think we need to do the same thing with flexibility of deployment in mind, particularly in manufacturing, and particularly with AI. We have a workforce that has developed intelligence into PLC for the past couple decades, but those platform vendors have built no hardware abstraction layer between the code and the PLC. You are writing for a platform. And that kind of thinking has sort of made its way into most OT level software development, where there is no abstraction between the code I'm writing and the particular infrastructure I'm deploying it against. In IT software, by contrast, for the past few years, we've been building our software more and more modular. We've been building it out of components, and those components are loosely coupled into a particular architecture and attached by well-defined interfaces. So it's the interfaces that are important, not the particular platform. We need to bring that thinking into manufacturing as we deploy AI, where the AI is built against information interfaces rather than a particular hardware vendor or even software vendor's ecosystem. And it's not just kind of habit that leads us down that path. Sometimes it's a business decision. There's an ecosystem play, or a vendor is trying to deliver the killer app for their platform. And that stifles innovation. It's not just bad software design. It makes it difficult to repeat or to try out the theory in different scenarios. So I think democratization, for me as a software nerd, means that as we build these AIs, we build them independent of particular platforms. We build them against well-defined information interfaces so that we can deploy them in different scenarios. We can make them available to a small manufacturer who has very limited infrastructure, and we can make the same AI available to a large manufacturer who not just has lots of infrastructure, but strong opinions on how their infrastructure is connected and should be used. We're democratized when we can try out these AIs, we can pursue science in a variety of environments, not just build it for a single one.
Thanks, Jonathan. Jeff, do you want to go next?
Sure, thanks. Building off of Jonathan, I think it's a very similar perspective from us, right? It's still a very expert-driven approach to this right now, from being able to get the vision system to perform, to getting your sensors to communicate through your I/O, to come up through either your PLC or your IoT gateway, then to be served through historians all the way up. So what we really need to do is to mature into this low-code object that we can connect through interface standards, make sure the data standards are there. I mean, we participated successfully in PACML and UPAC, which are controls standards for integration and the different S88, S85 structures. I think we need those kind of data standards, those kind of ways that allow the industry to talk the same language, no matter what we're doing, whether you're small to mid-size OEM, small to mid-size supplier, small to mid-size manufacturer, and then we can all speak the same language, buy into the same objects, reference architectures, and then really our subject matter expertise is our differentiating value. Because we really want everyone to be able to participate in machine learning AI, and we could do so through these standards, through these interfaces that we all recognize, the structures we recognize, and then the objects that will flow through that infrastructure. And then the differentiating value for the suppliers is how well does your platform allow that to happen on an end-to-end life cycle of machine learning for manufacturing. So I still think it's still very custom, it's still very specific. But as it plays out and we mature, I think that will be the tipping point by which everyone will participate successfully, is getting to data standards, getting to standard interfaces, getting to objects that will move throughout the architecture, and then getting the citizen data scientists, which are really the subject matter experts in their domains, to be able to participate in the data exploration. Right now, they have to wait for some expert to bring all the data to them. And then once the data is to them, it's not contextualized, and now their subject matter expertise has been diluted. So I would see if we can get those things together, we'll be able to invite subject matter experts from any field in manufacturing or others to really be able to perform, and then depend on a very standard, very proven, very reliable, modular, and agile infrastructure for manufacturing machine learning.
Thanks, Jeff. Waleed and Kelly, can you comment as well?
Absolutely. So I love the examples I quite honestly heard from Jeff and Jonathan about the pain points and how to overcome them with the right API, standardization, being able to drive really bridges of knowledges across the islands of expertise that do exist in today's world, which, by the way, ties in very nicely to how Jem offered the whole problem of democratizing the modernization with AI in the area of manufacturing. I mean, let's just talk about the elephant in the room. There is a conversation happening as we speak today that technology is going to take away jobs from manufacturers. But in reality, this is not the case. The World Economic Forum research has suggested that over the next decade, there should be around 75 million jobs that will indeed go away, but in reality, about 135 million new jobs being created. These are the AI and digital jobs that are in need of us to embed in our new thinking of manufacturing. Let's utilize the kind of disruption that we underwent last year to drive that change, because simply put, in times of rapid change, we cannot move ahead without considering the impact of new technologies like AI on people, on business, utilizing the impact on the environment and making the best out of it, and also building on what the society is driving for. Ethical AI and responsibility toward the community, augmenting our own human capabilities. Fundamentally, we have a lot of expertise in the area of manufacturing. These tribal knowledge can only be best captured if it gets well integrated with the AI in the workflow. Being able to drive that into a meaningful fashion that will enable our next wave of creators for them to drive that knowledge while also having the background of this tribal knowledge is extremely important. We're seeing these technologies transform manufacturing, boosting productivity, as we heard about quality and augmentation of factory efficiency and agility with teams, collaboration tools, mixed reality, remote assistance, IoT-enabled capabilities and AI. But at the end, if we're unable to tie them together and provide value to our community of manufacturers, the impact will be minimal. So we have to maintain that front and center, our thinking in the future.
Yeah, thanks, Waleed. Yeah, I guess one thing I'll double down on, and Jim mentioned it, everybody really mentioned it, on the data standards and connectivity, right? There's no connectivity, there's no data, there's no AI. And I think, one thing that's been interesting is in particular for medium and large enterprises, when you think about that, and we talk about pilot purgatory, it's much easier to do a pilot than to scale across an enterprise architecture. And so one of the things that we've been focused on from an educational perspective is promoting some of those real deep system engineering and architecture programs that have a manufacturing context within them. So that especially for the medium and large enterprises. I think there's some tailwinds for the topic we're talking about here. You think about, just Industry 4 in general, which has been around for the better part of a decade, at least the term that originally emanated out of Germany. But also some of the recent focus on overall digital transformation within organizations. You look at the DoD's strategy for digital engineering. All those digitalization, as Jim mentioned it, initiatives help build that foundation and infrastructure for the data that we need for AI. And then lastly, again, as mentioned, but I'll double down on it, that data science talent pipeline that has a context of manufacturing. They might not have to be the domain experts, but at some point, we got to get past hey, we're marrying up a pure data scientist with a pure domain expert. We need some data scientists that have that domain expertise that have been working in the industry. So growing that pipeline of folks that have that context, I think, is important. So just a couple adds there from me.
What a great collection of thoughts there. Thank you. So much to dive into, but in the interest of the short time we have together here, I have one more question I'd like each of you to briefly comment on. Try to keep it to 30 seconds apiece so we can leave more time for the audience Q&A. This is still clearly a pre-chasm market, to use Geoffrey Moore's term from a few decades ago, but it clearly represents an enormous opportunity. That's not in question. Many would say that it's an essential capability for us to develop here in the U.S. And globally in order to stay competitive in manufacturing. What guidance would you share with the different stakeholders in our audience? And maybe for the sake of brevity, pick a stakeholder group, if you would, as they consider how to best articulate their value and to participate in this space. Take that wherever you want to. And Jeff, I'll let you start.
Yes, sir. Thanks, John. I think the persona I would take on this is plant manager, right? So many of these endeavors, at least in my field, starts with the plant manager. They have to make a fateful choice to address their challenges and opportunities with technology, workflow, their people. So my advice to the plant manager is this is a journey, right? It's a journey of technology. It's a journey of foundational investment in your people, in your capital systems. It's a journey of learning how to use the data, to perform scientific method, to come up with insights, to inform your people, your operators, your operations managers. And it's a journey that will never end because the opportunities will continue to come. The solutions you find, you will deploy and manage over an infinite life cycle, yet the benefits are infinite as well. So my advice is there's really no time better than now with the emergence of technology, the emergence of committed people like the folks on this panel, the emergence of an ecosystem that's going to surround you. And it's not something that you can buy. You can't buy the digital transformation. You also can't buy machine learning AI. So you might as well roll up your sleeves, get your best people involved, and take the journey that will really create breakthrough performance for your sites and breakthrough performance for your customers and breakthrough performance for your suppliers. So, for a plant manager, the time is now, and we're here to support you, and it will be a wonderful yet challenging journey.
Jonathan?
Yeah, I think I'll echo most of that and maybe just up-level the audience. Everything Jeff said, but to the CEOs and CIOs and CTOs, this is a journey and now is the time to start. I think AI is the same kind of sea change that the internet was a couple decades ago. And yes, there's some hype, just like there was then, and there's some dangers in that. But there's an even greater danger in just sitting back and waiting to see how it all unfolds. I think most of the companies that did that with the internet aren't with us anymore. I think we're at the same inflection point with AI. You need to start now with your teams, with your processes. We talked about how it's easy to do a pilot. It's hard to scale that. And what that means is that you need to begin building your systems so that you can have repeatable solutions. You can't wait until you have a solution and then figure out how to repeat it. You need to start building up your infrastructure, your workforce, the skills within the workforce you have now, and then your pipeline. Who are you bringing into the company, and what skills are they bringing, so that we have some of these cross-discipline folks who aren't just experts in manufacturing or experts in software development or experts in data science, but can cross some of these boundaries and help you cross some of those boundaries. Just to be clear, start now, don't wait.
Let me change gears a bit and talk more about something that goes really hand in hand with smart manufacturing, which is sustainability. Fundamentally, to everyone's point, we are at an inflection point in the industry, and with the industrial processes accounting for almost half of our human species consumption of energy and 1/5 of the global greenhouse gas emission, not only is it the ethical thing to do as we start thinking of how to rejuvenate the industry we all are so eager and passionate about, which is manufacturing, and how we take it the next realm. Not only is it the right thing to do for our commitment to the environment, the communities we live in, but it's also the right business decision with circular economy driving us to collaborate on closed resource loops and the life cycle of products post-production into consumption, being able to drive value both financially as well as from a business competitiveness around climate protection and low carbon consumption, and utilizing credits associated with it and driving value add, not only for producers, but also for consumers of these products and how to manage all of that. This is a time of unprecedented opportunities that allows us to do the right thing, both from the technology with AI and smart manufacturing, but also for sustainability that we need to do in the environment we live in.
Yeah, I guess I'll focus on the technology roadmap owners within the industry. It's a long game, right? We need to be thinking about this in terms of 10 to 20 year strategies, and so you got to think about it more like the evolution of MapQuest to Waze or Google Maps, right? It was a long evolution from that, and it also took data and architectures and system engineering. And then I'd say as a tag on to that, make sure we're thinking about the talent pipeline. So that's also a long game to get the talent into the pipeline, the education systems, get the programs right, get them graduated and experience, right? So it's all about the long game.
Thanks, Kelly. Jim, last but not least.
Yeah, so I'm trying to absorb all the comments here. I guess I'm always guilty of trying to roll things up, so I'll try and do that since I'm last. I guess the persona I would take on is the industry overall. And when you, as was said earlier, when you look at other industries, manufacturing is actually one of the later ones, to begin taking on these kinds of things. So the opportunity's there, but there's actually quite a bit of room to learn from what has happened in other industries. So let's take advantage of that. The other kind of point is that we need to be careful not to fragment. We are naturally we naturally want to fragment or naturally want to compartmentalize. But if you go back to quality assurance, that actually has to occur on the factory floor. But we want to talk about visibility. We want to talk about resilience. We want to talk about being able to take actions in the face of disruptions at the supply chain level. So how do we get there? You actually have to have industry-wide strategies. So AI actually becomes not only the means to these, but it actually facilitates how you do these. So you need it in both directions going forward. So we're currently right now managing to the greatest complexity as opposed to the greatest simplicity going forward. We need to kind of invert that. We need to basically rethink a number of things that are in the way. Intellectual property needs to be recalibrated. The way we look at risk needs to be recalibrated. The way we look at tools and people and the interrelationship needs to be recalibrated. But if we can do that as kind of a holistic grouping, we actually have our hopes of getting there. If we fragment, we're in trouble. So that's why we kind of characterize these things. It has to start at the factory floor. The factory floor has to grow somehow into the supply chain. The supply chain somehow needs to benefit back to the factory floor. The ways to do that, if you look at other industries, is to think about how do you actually exchange data, share it, pool it, combine it, work with it in some kind of collective fashion. So there's an industry-wide strategy there. And you also need to get these capabilities, tools, and the people in the right place. And one of the biggest fragmentations that we need to watch out for is not to upskill people, but not have the tools for them to go do something, and vice versa.
And with that, we have the opportunity to transition to our audience Q&A. There's a long list of questions from the audience this afternoon, and we have time for only a couple. I think it was a fantastic dialogue. We will absolutely respond to each of the questions you've posed in the next couple of days, but let me ask this question first. What, in your opinion, is the easiest AI project to deploy? And if I can tack on the second part of that, what made it the easiest? Jeff, perhaps you can comment first.
Yeah, thanks, John. I think the one that comes to mind for me is in the maintenance area. Many of us, as we bring our automation equipment or manufacturing equipment into the plants, we've studied from an engineering standpoint or an operating standpoint, key systems, their major components, and what are the failure modes of those components. P&G and much of the industry still does time-based maintenance based on its whatever research you've done on the failure modes. That's clearly not appropriate anymore. We should be moving to predictive and condition-based maintenance. So all of the previous understanding we've had from engineering and operations, turning into hypotheses, turning into a data model you can harvest from the equipment, and then turning them into algorithms that can run condition and predictive maintenance on those major spares, major componentry, to me is still the most ripe for the taking, and it also doesn't require a lot of multi-dimensional understanding that you haven't already developed either in operations, manufacturing, engineering. So I think there's still a ton of value to be harvested from the maintenance of our equipment using machine learning, and it's there's really no excuse for all of us not to be doing that at this point in time.
Yeah, you guys hear me okay?
Yeah, you bet.
Great. Yeah, I would say, without going into a very specific project, right? Finding a project that, or an area, even if the value's not the greatest value, that is digitized. So if you have something that has digital data in a structured architecture or structured data set, those are some areas where we've looked at just to get your feet wet if you're really starting at the beginning. I think that was a great example, just given, which was a little more mature. But for those who are really just dipping their toes in, look for areas where you have data that's already digitized in a structured data set.
Great observations, gentlemen. I'd like each of you to briefly take a bit of time and respond to this question. We know we're making progress. We haven't yet accomplished the idea of scaling up of artificial intelligence. What are we doing to drive that at scale? And I'll just add my point of view here. We have a broad set of perspectives represented here. If you would each take a few seconds from your own perspective to sort of share your role in driving the scale up of AI machine learning on the plant floor, I'd appreciate that. Thanks. Jim, I'll ask you to go first.
I guess if I tackle that question, it's a little bit about where I had ended the previous one. I'm spending quite a bit of time on the AI industry-wide data sharing. And the question there is, how do you get to curated data, and how do you put it in a form in which it can be, in fact, shared with trust? It goes back to Jonathan's comment as well, because we have so many coding structures that embed the data and make it hard to pull out. So we need to work with the infrastructure pieces as well. But that's a key one in this business about how to share it with trust and how to share meaningful data with trust, I think, is large. The other one, just to very quickly say, is you can't have the data without the models and the capability and the solutions. So you actually have to pair those. And this goes to the workforce. I think Waleed had said this. It's one thing to upskill the workforce. It's quite another to have the tools ready to go and the capabilities and the solutions. So you upskill the workforce with those so that the benefits are going along together. So this is where the fragmentation becomes important, or avoiding it. So I think those two areas become really important, for the factory floor and the supply chain to come together.
Yeah, I think this is a great segue. I think I definitely agree with what Jim mentioned. I would kind of add a bit of a contrasting picture here. I think we're also at a stage of scaling and distribution of AI and services with the cloud services. It makes that journey easier, but I couldn't underline enough the importance of what Jim mentioned about the data vitality and the data sharing across the industry, while also maintaining there will always be a set of these data sets that are crucial to the business competitiveness. So being able to dissect one versus the other while utilizing the massive scaling that cloud is providing us with, I think would be key to our success in the future.
So maybe I can add to this conversation. I would say, inside of Procter & Gamble, we established a strategy called Smart Platforms, and the term platform is what I want to talk about. First, we still are upskilling all of our people in the plants, as well as in engineering in the staff positions. But what we're really focused on is trying to establish a platform of products and services, right? So when I say products, I'm talking about the technology stack that's necessary to bring data from the sensors through the control layer, through the other layers of the architecture, so that data can be served to the machine learning process, and then bring them back down as algorithms that can run at the edge. So what is the product that we need to package between our industry providers and what we need inside of P&G and for our suppliers and for our plants? And then services, and this is probably the most important part of it. When I say services, there is a clear method of manufacturing machine learning that needs to be taught, trained, and delivered to our people so that they can repeatedly do this process of harvesting data, contextualizing data, exploring the data, develop models, train the models, deploy the models, and then keep those models healthy. So that's something new to us in P&G, and I think in the industry. So my answer is we're developing products and services that are a bit of a packaging of what Microsoft and others are providing us to deliver the technology stack in an effective, affordable, modular, and adaptive way, and then giving a methodology by which that technology can serve the data and then follow the whole method of manufacturing machine learning over its life cycle. So exciting that we've gotten that clear. We went from solving problems for 2 years, coming in and doing all the work and then leaving, and then nobody could sustain anything, to now knowing we got to teach them how to fish, and fish with a platform that they can go out and do this day in and day out without the experts holding their hand all the time. So for P&G, it's developing products and services that are packaging the industry solutions so that we can deliver smart platforms.
I'll answer with a CESMII perspective. We are investing in a proliferation of AI and apps that run at an abstracted level from the OT data source. I heard this great quote on a call with a member the other day. Everybody thinks that data is oil. Data isn't oil. It's sand. We need to process it. We need to get it ready. So the other big kind of strategic investment from CESMII's perspective is information interfaces. Those information interfaces can be fulfilled by a variety of sources. We're fairly agnostic on where the data comes from, but we want to see some common structures for common problem sets emerge so that we can focus the problem solving on getting insight out of that data, regardless of what the underlying infrastructure that serves it up is.
Thanks, Jonathan. Kelly, last but not least, why don't you wrap things up for us here?
Yeah, no, those are all great inputs. And what Jonathan just mentioned is one of the reasons we participate with CESMII. It's great stuff. I would say, a couple of things we're focused on when you really look at the how the digital systems interact together, establishing that foundation. There's a pretty significant aspect of systems engineering that goes into that. Not just good software engineers and good manufacturing engineers. We need that system side to really establish the right architecture, look at the data flows in much the way you would a complex product. I think the other couple of areas we're working on, also developing the use cases that are high value, working on the education pipeline, as everyone's mentioned, both the education and the upskilling, and then aligning with our customers on where that value gets applied to them, right? So there's a value to both our corporation as well as the customer. So making sure that we're well aligned with where the value lays with the customer.
Thanks, Kelly. I think that's a great synopsis, a great summary. So it kind of looks like we're going to end where we started, emphasizing that scaling AI, machine learning, and manufacturing is about the entire ecosystem, from the educators to the practitioners to the implementers to the leaders that make choices about where to invest, and that this is indeed a priority for them. And as was said just earlier this hour, the notion that this is a journey that we need to invest in, and that we need to begin building some equity in. So we're over, but let me close this panel by saying a big thanks both to the audience that's joined us and stayed with us here, but also to this distinguished group of panelists. We're grateful for your time and for your partnership with us here at CESMII as we focus on and address these really important topics for manufacturing here in the U.S. So thank you all. And like I said, we'll follow up with the many unanswered questions in the days to come as directly as we can. Thank you.